to identify the key information of the function below. So this first function in number 1 is an exponential decay function because my base is between 0 and 1. So I know that it is going down when we look from left to right. We have 2 transformations on this function. So one that moves it horizontally and the other that moves it vertically. Our horizontal translation is always the opposite of what the number says. So this moves horizontally 3 to the left. So inside is opposite, outside is same. The -4 is our vertical translation, and it moves it 4 units down. On exponential functions, we have horizontal asymptotes that start with y equals. A couple ways I can find that. I can look at where my function starts to level off here, where my graph is going to get super close to that asymptote but won't cross. I can also pull out this k value at the end. That also gives me my asymptote. My domain, all possible x values, is going to be -infinity to infinity. My range starts at -4 and goes to infinity. Notice that -4 gets a parenthesis because our function does not exist at -4, rather approaches it at the asymptote. As x approaches infinity, our right arrow, our right side, is going to -4. And as x approaches negative infinity, that means look at the left side, that is going to positive infinity. Taking a look at number 2, we're doing the same thing. We're still identifying the key information, but let's note that this one represents exponential growth rather than exponential decay. Again, it has 2 transformations, a horizontal that moves my function 2 to the right, and a vertical that moves my function 4 units up. Again, I have a horizontal asymptote starting with y equals. Make sure that we're not just putting the number there, but rather putting y equals. This is equal to 4. And again, I can see that from my graph or from the k value at the end. My domain is still the same, -infinity to infinity. There's no x value that I could not put into this that would give me a y value. My range starts at +4 and goes to infinity. So when we're looking at growth and decay, find where your graph starts to level off, where that asymptote is, and that is related to your range. As x approaches infinity, means look at the right side. The right side is going up to infinity, and the left side is going down and is approaching 4. So moving on to question 3, we are graphing both exponential decay and exponential growth. Question A, that's going to be decay because my base is between 0 and 1. So I need to go ahead and build my table. Now on the test, we're going to ask you to graph at least a couple key points. I like to graph a bunch of points so I can see a good picture of what this graph is. But as long as we know that our table should start at -4. And that's because whatever our horizontal translation is moves my table accordingly. So I'm going to start at -4. So I take the opposite. I go 2 below and 2, let me make that a -3 there, and I go 2 greater. So from here, this is just taking our values, putting it in where it belongs. So let me show you what that would look like if I took -6 and substituted in. I would want to type in 1/3, then my caret button of -6 plus 4 minus 3. So when I type that in, 1/3 to the -6 plus 4, making sure I put parentheses where they need to be, minus 3, I should be getting +6. As I go through, I'm just going to change that one number to the new value that we're substituting it in to find my other y values. So next one, it should be at -2. -3 goes to -2.7. We're going to notice that we have some decimals on these, and that's totally fine because we are slowly approaching that asymptote. And we got about -2.9 here. So I'm going to go ahead and graph it. So we should be at -6.6, -5.0, -4, -2, and then our couple of decimal points get super close to that asymptote but won't cross. So then I'm going to sketch in my decay function. Let me make that a little bit straighter. I'm going to try my best on my tablet here. noting it should not cross where that asymptote is. It should start to level off. For question B, we're going to go ahead and do the same thing. We're going to build our XY table. This one is going to be exponential growth because my base is bigger than 1. I'm going to start at positive 2 in my table because my horizontal translation is negative 2, and I take the opposite of that. And then I fill in 2 above and 2 below. And I'm going to go ahead and do the same thing. Take my values, substitute it in for x, and then see what I get. So if I've got 3 to the 0 minus 2, and then I subtract 4 after that, I should be starting with negative 3.9, about negative 3.7, negative 3, negative 1, and positive 5. So once I build my table, I'm good to go ahead and graph it. So 0, negative 3.9, negative 3.7, and increasing from there as I graph my points. Again, I'm starting along that asymptote, should be pretty flat, and then rising from there. So looking at question 4, our directions say to expand. So to expand a log means to take one log and make it multiple. So I'm going to start this one by separating, excuse me, I'm going to separate all those logs into their own, noting that square root of c is really c to the 1/2. So I see 3 variables. I know I'm going to need 3 logs. So log a to the 5th minus log b cubed minus log c to the 1/2. Noting that because b and c were in the denominator, they need negative signs. I finish this by throwing my exponents to the front of the log in which they came from. So my final answer is 5 log of a minus 3 log of b minus 1/2 log of c. B is going to be the same thing. Again, I see 3 variables. I know I'm going to need 3 different logs. Even though this is a natural log, that's totally fine. It's a type of log. I'm still going to separate it out. No need to change it to log base e. Cube root of y squared is really y to the 2/3. And as I separate this out, this is going to be natural log of x to the 7th plus natural log of y to the 2/3. Both of those two things are positive because both x and y were in the numerator, minus natural log of z. And just like the previous one, I'm going to finish this one out by throwing those exponents in front of the log in which they came from. So my final answer is 7 natural log x plus 2/3 natural log y minus natural log of z. Moving on to question 5, our directions say to condense. So unlike expanding, I'm taking multiple logs, putting it back together, and making it one log. So we're on expanding. The first thing that we do is apply our product and quotient properties. In condensing, the first thing that we do is apply power property. So I'm going to go ahead and take a look at number 5a. So I'm going to start by throwing those powers back on the variables in which they came from. So I've got log a to the 6th plus log b squared minus log c to the 1/4. And I'm going to go ahead and change c to the 1/4 to be 4th root of c. That is better notation, minus log of d. So I still have multiple logs. Now I need to put this back together and make it one log. Things that are positive go on top. So a to the 6th and b squared go on top. And both of our negatives will go along the bottom. So log of a to the 6th, b squared divided by 4th root of c times d. And finally, same thing on 5b. I'm going to start by throwing my exponents back onto the variable in which they came from. So log base 2 of x minus log base 2 of y cubed minus log base 2 of z to the 4th. Now notice that these all have base 2. That has no impact on your condensing or expanding as you're applying your properties. That is just the type of log that we have. You have to include it every time and as part of your answer, but that will never change. So then I'm going to write my final answer as a single log, base 2, and decide where things go. So this log base 2 of x is the only thing that's positive, so the only thing that will be in the numerator, and y cubed and z to the 4th will both be in the denominator. Question 6, we are now talking about our application problem. So number 6, it says Miss Hurst bought a car in 2015 that was worth $24,000. The car decreases in value by 12% each year. So this is going to be our simple growth and decay setup. So my formula that I'm going to use is y equals a times 1 minus r, because we're talking about decay, to the t power. So if I do these problems, the first thing that I do is highlight any key information that they give me. So they tell me that the car started at $24,000 and is decreasing by a rate of 12%. And I know 12% as a decimal would be 0.12. So I take that decimal point, move it 2 units to the left. So question A is asking us to write a function that models the scenario. So that means using the 2 pieces of information, the A value and the rate, to write a general formula to be used to find any cost along the way, depending on what t is equal to. So from here, write a function that models the scenario. Y equals 24,000 times 1 minus 0.12 to the t. I'm going to want to finish it out by actually doing that subtraction. So my final function is 24,000 times 0.88 to the t power. Question B, how much was the car worth in 2021? So if we're starting at 2015 and we want to know what 2021 is, that would be when t is equal to 6. So I'm going to take 6, put in for t. So y equals 24,000 times 0.88 to the 6. This is just a plug it in type problem. So I'm going to type it in my calculator exactly how I see it, making sure I've got parentheses around the 0.88, taking it to the 6th power. So after 6 years, that vehicle should be worth $11,145.70 when I round it. All right, and this should say question C, but either way, when will the car be worth half its original value? So I know that they're asking me a when question. That means that I'm solving for time. So t should be my unknown that I'm solving for. They also tell me it should be worth half its original value, which would be 12,000 equal to 24,000 times 0.88 to the t. I'm going to start this one by dividing by 24,000 on both sides. I am absolutely not allowed to multiply 24,000 by 0.88. When I do this division, I get 0.5 equals 0.88 to the t. This problem will require a log, that is base 0.88 of 0.5 equals t. We're then going to go ahead and do the division and see what we get. So when we divide log of 0.5 divided by log of 0.88, we should get about 5.42 years. So after that amount of time, the car would be worth half its original value. To an account earning 5% compounded continuously. So I know that I'm now going to be using that formula A equals PE to the RT. Please make sure we have that memorized for your test Thursday. So it says in question A, how much will be in the account after 10 years? So I'm going to, again, highlight the key information that they give me. So I know my initial amount is $2,000 and our interest rate is 5%. As a decimal, that is 0.05. So they want me to say how much is in the account after 10 years. So it's going to be A equals 2,000 e to the 0.05 times 10. This is just one of your plug it in type problems. To get E, you hit second ln. So you're typing 2,000 e to the 0.05 times 10. Make sure you have parentheses in the correct spot. So after 10 years, there should be $3,297.44 in that account. Question B says, after how many years will it be worth triple the initial deposit? So if we initially put in $2,000 and we want to triple it, that's 6,000 equals 2,000 e to the 0.05 times t. So t is going to be our unknown. That's what we're solving for. So I'm going to divide by 2,000 on both sides. And we get 3 equals e to the 0.05 times t. I need to convert this to log form that has base e, and then the other two things swap. But I know that a log with base e is a natural log. And then I'm going to divide by 0.05 on both sides. So I can do this now in one step. I'm going to type natural log 3, close my parentheses, divide by 0.05, and I get about 21.97 years. So question 8 and all of its pieces are now solving. We've done a lot of solving over the last couple of weeks, so hopefully this is fresh in our mind. So taking a look at the first one, this is going to be solving by getting the same base. So I'm going to make 125 be 5 to the third and keep the x up there. I'm going to make 1/5 be 5 to the -1. Anytime you have a fraction, we want a negative exponent, and I'm going to keep that 2x minus 1 up there. But now that I have the same base, I'm good to get rid of them and set my exponents equal. I'm going to go ahead and distribute that -1 at the same time, and now I can solve. So I'm going to add 2x on both sides so that 5x equals 1. I divide by 5, so x is equal to 1/5. Question B, I'm going to go ahead, use my properties to combine these to be x times x plus 3. And I know it's times because there's a plus sign between them. This is now a log equal log problem where I'm allowed to get rid of the logs and set the insides equal. I'm going to go ahead and distribute as I go. So x squared plus 3x is equal to 70. I'm going to move this 70 over so that our function is equal to 0, allowing me to factor. So the two numbers that work are -7 and +10, so x plus 10, giving me solutions of 7 and -10. But let's remember that we have to check for those extraneous solutions. So if I take 7 and I substitute it in for x, log of 7, that's good. Log of 7 plus 3, +10, that's good. So extraneous solutions come from negative or 0 within the log. So if I take -10 and I put it in for x, that is automatically a problem. So that one goes away. My only solution is +7. Question C, similar to B, this also involves a property. So I need to go ahead and combine these to make it log base 3 of x plus 9, but this time divided by 7 because we have that minus sign between them here. That is quotient property. This is not a log equal log problem, though. I have to instead convert it to exponential form and then solve. 3 squared is 9. And if I'm solving for x, I'm going to start by multiplying by 7 on both sides. So that 63 is equal to x plus 9. To get x by itself, I subtract 9 on both sides, and 63 minus 9 gives me 54. Moving on to question D. This is going to be similar to question A, where I have to get the same bases. They're going to be base 3, and the only one I need to change is that 9. So I'm going to make that 3 squared and keep the x up there, times 3 to the -x equals 3 to the 2x minus 1. I'm going to go ahead and use my properties to make this 2x minus x, which is really 2x plus -x, but I can go ahead and combine it because I want these to be balanced on both sides, because if we have the same base, I am allowed to set the exponents equal. At the same time, I know that 2x minus x is just x, so x equals 2x minus 1, and then I solve. So I subtract 2x on both sides, and I'm left with -x equals -1, and if I divide by -1, x then is +1. Moving on to question E, my goal on this is to get this exponential to be by itself. So I'm going to go ahead and start it by subtracting 2 on both sides. So 3 to the x plus 7 equals 62. So I am never going to get 62 to be base 3. So instead, I need to convert this to log form, where my base is 3 and the other two things switch. To evaluate that log, I do log 62 divided by log 3, and I will eventually be subtracting 7. So log 62 divided by log 3, that gives me about, we'll say 3.76. I subtract 7, and I get about negative 3.24. Moving on to question F. Question F, I still want to get that exponential to be by itself, so I'm going to start by adding 5, not 15, but 5 on both sides. So 2e to the x minus 3 equals 16. Then I'm going to divide by 2 to clear that out. So e to the x minus 3 equals 8. Now we saw an e problem previously that I know I need to convert. So log base e of 8 equals x minus 3. But I know a log with base e is a natural log. And then I'm going to add 3 to that. Natural log of 8 is about 2.08. And if I add 3 to both sides, x is about 5.08. And finally, taking a look at my last two questions, G and H. For G, my goal is to get the log to be by itself. So just that piece alone. So I'm going to start this one by adding 9 on both sides. So negative 9 log base 2 of n plus 1 equals negative 27. I divide both sides by negative 9 so that log base 2 of n plus 1 equals 3. Now note that I am absolutely not allowed to subtract that 1 that is inside the parentheses until I am able to convert it. So I'm going to convert this to exponential form, where 2 to the third equals n plus 1. I know 2 to the third is 8. I subtract 1, so that tells me n is 7. If I plug 7 back in, 7 plus 1 is a positive 8, so that log is good to go. H is going to be very similar to the process that we did in F, where I start by subtracting 6 on both sides, convert to log form, and again, I know a log with base e is a natural log. Natural log of 11 is about 2.40. And then we subtract 7, and we get about negative 4.60.